Hello Year 9s, this video that I'm asking you to watch is an accompanying video for the YouTube video that I'm asking you to also watch, which is the actual experiment to make an insoluble salt by precipitation. So the insoluble salt that's being made in the video is magnesium carbonate. The other product that is made is soluble sodium sulfate. I'm just going to put aqueous there. The reactants that you use right at the very beginning are soluble sodium carbonate, which is what I'm labeling here, and also soluble magnesium carbonate. Now we've got some rules that we've already been through about which salts are soluble, but just to run through them very briefly, just in case you need a reminder. All sodium, potassium and ammonium salts are soluble. All nitrates are soluble. All chlorides except silver and lead chloride. All sulfates are soluble except calcium, barium and lead sulfate. All soluble carbonates include sodium, potassium and ammonium carbonates, but all other carbonates are insoluble. So you can see over here, sodium carbonate is one of those soluble carbonates. On the right hand side we've got magnesium sulfate. All sulfates are. This is soluble, it's not calcium or barium or lead. One of the products that happens to form is sodium sulfate. Again, it's another sulfate. It's fine, it's soluble, but the magnesium carbonate is the insoluble salt. A little bit of extra information. Each one of these sodium ions, and you really need to start getting a working knowledge of the charges of the ions as well. Each one of the two sodium ions has a positive charge. The carbonate ion has two negative charges. We've been working with carbonates. Magnesium, it's group 2, loses 2 outer electrons. My handwriting's getting really neat now. Mg2+. The SO4 SO4 is 2-. So you can see that these two balance each other out. That's why you need one of each. But you need 2 of the sodiums to balance out the double negative charge of the carbonate. And essentially what happens is that these sodium ions get paired up with this to form sodium sulfate, while this carbonate finds itself pairing up with the magnesium, because when you have a solution, everything mixes together. Okay? As soon as the magnesium ion meets the carbonate ion in solution, they immediately bind together and they form this insoluble magnesium carbonate. So, going through the actual video itself, those are the ingredients that are used. A little bit of extra information for you, background information to make it quite interesting. Magnesium sulfate is actually known as Epsom salts. Not too far away from where I grew up, in a town called Epsom, which is a spa town in the United Kingdom, in a county called Surrey. The water found at that spa town contains the salt in quite high concentrations. Epsom salts are rarely used nowadays, but were used in medicine as a purgative. Sodium carbonate is found naturally in high concentrations in the soda lakes of Kenya and Tanzania in East Africa. It's also manufactured in large quantities and used in many different industries. Sodium carbonate is very, very ubiquitously used. If you are using a detergent powder at home, you are looking at a massive box with primarily sodium carbonate. You also use it in glass as well. There's some extra information about magnesium carbonate and sodium sulfate that I've left on the screen for you. So you can see the Epsom salt just located there, and you've also got that that baking soda. That looks like washing soda actually, but it's baking soda is fine. So the two powders are weighed out, and then water is added, and the water is stirred, and the reaction starts off as an endothermic reaction. So as you watch the video, you'll actually see that the temperature goes down. You then find that there's condensation on the outside of the beaker as that happens. You'll get some carbon dioxide bubbles appearing. It doesn't boil. You set the heat to maximum to get the reaction going, and then you form a precipitate. The actual experimenter is using a metal magnetic stirrer with a display that, a balance that allows you to heat the solution. So it's called a heat plate. So it's a magnetic stirrer that stirs and stirs constantly, and it's actually a hot plate as well. There's the filtration. So the filtration separates out the magnesium carbonate. What the experimenter does is removes the water, just dries it, and then attempts to purify the sodium sulfate solution. There's a little bit left, but he goes through that as well, and he gets quite a nice yield, particularly with the sodium sulfate. So that pretty much is the video. Watch the video because it is an experiment in action. It is talking to you about the reaction that you will then find in your quiz. So do watch it very, very carefully, and best of luck watching that video.